In the farthest reaches of the solar system, where light is faint and the void stretches on endlessly, lies a world unlike any other. A world where winds are not merely a gentle breeze, but forces so powerful they defy the imagination. Welcome to Neptune, the eighth and most distant planet from the Sun. The very air here is a whisper of mystery, swirled in an atmosphere of whirling gases, dark clouds, and violent storms. With its rich hues of deep blue and purple, Neptune is not just beautiful. It's a world of extremes, with winds that rage faster than anything we've ever encountered. It is here, on this distant, ice-cold world, that we encounter the fastest winds in the entire solar system. Winds so fast, they can reach speeds of 1,500 miles per hour, 3 times faster than the speed of sound. These winds don't just swirl gently. They tear across Neptune's vast atmosphere with an intensity that dwarfs anything on Earth. And while this might seem extraordinary, it raises a much bigger question. What is driving these winds? What forces are at work on a planet so far from the Sun, where heat is a scarce resource? Let's venture into the heart of Neptune and uncover the secrets of its extraordinary weather. To understand Neptune's winds, we first must delve into its atmosphere. Neptune is a gas giant, meaning it's made up almost entirely of gases, with no solid surface to stand upon. The outer layers are composed mainly of hydrogen, helium, and methane, and beneath these swirling clouds lies a thick, dense core of icy rock. The upper atmosphere of Neptune is a striking blue, a color caused by the methane, which absorbs red light from the sun and reflects back a rich, deep azure. But beneath that vivid hue, violent storms rage in an environment unlike any we've encountered elsewhere. One of the most intriguing aspects of Neptune is its internal heat. Despite being so far from the Sun, Neptune emits more heat than it receives. In fact, it radiates about 2.6 times more energy than it gets from the Sun. This surplus of heat is a puzzle scientists are still trying to solve, but it likely plays a crucial role in driving Neptune's atmospheric dynamics. This internal energy could be contributing to the extreme weather conditions and wind speeds, creating rising and falling currents in the planet's atmosphere, much like the convective currents in the Earth's oceans. With this heat acting as a source of propulsion, the atmosphere is set into motion, creating powerful wind systems that rage across the planet's surface. Now, let's turn our attention to the winds themselves. On Earth, we're used to wind speeds in the range of 30 to 50 miles per hour on a breezy day, with powerful hurricanes and tornadoes reaching speeds of over 200 miles per hour. But on Neptune, the winds defy all comparison. The highest wind speeds recorded on Neptune are an astonishing 1,500 miles per hour, 2,400 kilometers per hour. These aren't just gusts or fleeting bursts. They are constant, relentless currents that sweep across the planet's atmosphere, driving a complex system of global winds and creating dynamic, ever-changing weather patterns. In comparison, the fastest wind speeds on Earth, the most powerful tornadoes, reach only about 300 miles per hour. Neptune's winds, then, are 5 times faster than the most intense hurricanes we can imagine on Earth. But what fuels these unearthly speeds? The key lies in the planet's internal energy, its rapid rotation, and the unique composition of its atmosphere. Neptune's day lasts just 16 hours, meaning the planet spins rapidly, almost like a top. This swift rotation amplifies the winds, stirring them into massive cyclonic systems that cover vast regions of the planet. With winds that fast, Neptune's atmosphere is not just a place of gentle breezes. It's a stormy, tumultuous world home to some of the most violent weather in the solar system. One of the most famous and mysterious of these storms is the Great Dark Spot. In 1989, when NASA's Voyager 2 spacecraft passed by Neptune, it discovered a massive storm system, a huge, dark vortex similar to Jupiter's Great Red Spot, but much younger and more active. The Great Dark Spot spanned over 8,000 miles, 13,000 kilometers, in diameter, and its winds were estimated to reach speeds of 1,200 miles per hour, faster than any storm on Earth. What makes Neptune's storms so fascinating is their ephemeral nature. Unlike storms on Earth, which often follow predictable cycles, Neptune's storms can appear and disappear within just a few years. The Great Dark Spot, for example, was gone by the time the Hubble Space Telescope observed Neptune again in the early 1990s. This dynamic, ever-changing nature of Neptune's weather systems adds another layer of mystery. Why do the storms vanish so suddenly? And what does that tell us about the deeper atmospheric processes at work? In 1989, the Voyager 2 spacecraft made history by becoming the first and only spacecraft to pass by Neptune. For 12 years, Voyager 2 had been traveling through the solar system, but it was Neptune that would prove to be its grand finale. As Voyager 2 flew past the planet, it sent back a treasure trove of data about Neptune's atmosphere, magnetic field, moons, and, of course, its winds. The spacecraft's flyby allowed scientists to make the first direct measurements of the planet's wind speeds and weather systems. Before Voyager's mission, Neptune was largely a mystery, a faint blue barely visible from Earth's telescopes. But thanks to its journey, we learn more about the intensity of Neptune's storms, the behavior of its clouds, and the surprising dynamics of its winds. The spacecraft showed that Neptune's atmosphere wasn't uniform, but rather, it was a swirling cauldron of powerful, chaotic currents. Yet, despite the wealth of data Voyager 2 provided, many questions remain unanswered. What causes Neptune's storms to form and dissipate so rapidly? What lies deep within the planet, fueling these extreme weather patterns? While we have learned much about Neptune's weather, the mysteries of its winds are far from solved. Neptune's winds are an enigma, faster than anything we experience on Earth, but driven by forces we are only beginning to understand. The question of why Neptune's winds are so fast, despite the lack of heat from the sun, remains one of the great puzzles of planetary science. Could internal heat from the planet's core be the main driver, or is there a deeper, unknown mechanism at work? Could Neptune's chemical composition, rich in methane and other gases, play a role in these powerful atmospheric currents? Some scientists believe that deep within Neptune, beneath the icy clouds, is a complex interplay of heat, pressure, and gravitational forces that fuel these intense winds. And perhaps, in the future, as our technology advances, we'll have the tools to finally unlock the secrets of Neptune's atmosphere. Neptune's winds are a reminder of the sheer power and mystery of our universe. These winds are not just the fastest in the solar system. They are symbols of how much we still have to learn. They speak of distant forces, of unseen mechanisms, and of a world that, despite all our exploration, still holds many secrets. As we continue to study Neptune, we are not just learning about a planet at the edge of our solar system. We are learning about the forces that shape all worlds, the unseen currents, the forces of heat and gravity, the complex interactions between a planet's atmosphere and its internal energy. One day, humanity may journey to Neptune. We may send probes deeper into its atmosphere, and who knows, Perhaps we'll even send a human mission to unlock the mysteries that lie beneath its swirling clouds. Until that day, Neptune remains a beacon, a world of extreme beauty and untamed power, where the winds blow faster than sound, and the secrets of the universe are still waiting to be discovered.